Hey guys, so today I'm making a video on gravitational potential energy. So, um, let's start with reviewing what we learned in grade 11. And for grade 11, we said that gravitational energy, or let's say gravitational potential energy, equals mgh. And this works if you're very close to the surface of the Earth, because um, in that distance, gravity, the g, doesn't change very much. So it's safe to say that it's the same number throughout. But this year, we're uh, considering situations where we're very far from the surface of the Earth, like in space. And when you get further from Earth, the gravity acceleration is less than it is on the surface of Earth. And the formula for that is G equals big G, big M over R squared. This G, the big G, is a constant, and it equals 6.67 times 10 to the negative 11. And then M is the mass of a planet usually, and that is, let's say, Earth. And then R is the distance between the distance away you are from the center of that mass. So this formula I derived from Fg equals mgmm over r squared, which is the force of gravity. So if we consider finding the energy now, it would be just force times distance, right? And that is our work, force times distance. So if we consider it to be force times distance, it would be g m m over r squared times distance. But actually distance is the same as r, so we can multiply it by r. And here you see the r's cancel out, so we get g m over r. But this is actually wrong. The actual formula for Eg is negative g m over r. Why is that? It's a very interesting question. So I'll explain that to you guys. So first, we need to look at the big picture. And let's start by drawing Earth. This here is Earth. This is our big mass, the big M here. And we also need to find where gravitational energy is the maximum. And if we think about it logically, gravitational energy increases as we move away from the center of the Earth. So that means that it's at its maximum when r is equal to infinity. And let's just say that is right here, from this distance to the center of the Earth here. And if we use the formula again here, EP equals negative g m over r. So then it would be negative g m over infinity. If you didn't know, when you divide by infinity, the number becomes 0. So that means at this point, the gravitational energy is 0. But now, if we take another point, let's say right here, this one it's less than this one. So that means the gravitational energy has to be less. And that's why it becomes a negative number. Because if we need a number less than 0, then it has to be negative. And yeah, that's all. Thanks for watching.